By the end of this lesson, you should be able to graph a linear inequality with two variables. Okay? So when you're graphing inequalities, what we're trying to do is show the points that give a true statement in the inequality. So anything, for instance, if you look at ours, y is less than or equal to negative 3x minus 2. So for this, let's talk about graphing y equals negative 3x minus 2, because all of those points would work in this inequality, because remember, it's or equal to. So the y-intercept is negative 2. The slope is negative 3, so it'll go down 3 over 1, which would be about here. Notice that matches that line. And all of those points on that line would give me a true statement in the inequality, because they would give me an equal to. Now, because it's less than or equal to, what we want to do is also find points that work in the inequality. So find points that would give us a less than. So let's look at the point. They say choose 0, 0, and negative 2, negative 2. So the point 0, 0 is right here. And if we substitute that into the inequality over here, so I say, all right, y is 0, x is 0, and I substitute that in. So negative 3 times 0 minus 2, 0 minus 2 is negative 2, and I get 0 less than or equal to negative 2. Well, that is not a true statement. Okay, that is not a true statement. And actually, we should probably cut it off right here. So it actually should be the box around just this guy. Okay, so that point doesn't work, and in fact, any point on that side of the line would not work. So if one point on the side of the line doesn't work, then none of them do. So then we're going to check the point negative 2, negative 2. And that's the point right here. Okay, and when I substitute that in for y and for x, I get negative 3 times negative 2 is 6. 6 minus 2 is 4. I'm not sure why it's over here, which is negative 2 is less than or equal to 4. So that point works. In fact, all the points on that side would work. Okay, so I would shade that half plane. So again, everything in the shaded region and all the points on the line, if I substitute them back into the equality, would give me true statements. If it was just less than and not less than or equal to, then my boundary line would be dotted, and then I would shade underneath. Okay? I would shade underneath that line. Because that dotted line is saying, hey, this is up into this point, all those points work, but nothing on the line works because it's not or equal to. Again, we're going to use Desmos as a tool to help us solve and graph each of these inequalities. So first, let's look at example 1. It's y is less than 4. So I type y less than 4, and you can use the keyboard less than. Also, if you hit the keyboard symbol in Desmos, there'll be a bunch of symbols that pop up, and one of them is the less than symbol. So all my points were y is less than 4. So if you notice at the graph they have, there's a boundary line at 4, and notice it's dotted because it's not y is less than or equal to 4. It's y is all the points where y is less than 4. So where y is 4, I'm going to put a dotted line, and then all these points are less than that, and that checks out because all those are beneath that 4. So all those y is less than that. So right underneath, like y is 3, that's less than 4, y is 1, y is 2, and so on all the way down. So that is a graph of all the points that work in that inequality. Example 2 is x is greater than or equal to 1. So all the points where x can be 1, and all the points where x is bigger than 1. Again, we're going to do a solid line. So if you look at Desmos, it graphed a solid line. Again, to get that symbol, if I click on the keyboard tool, that symbol all those inequality symbols are right there. Okay, so I'm going to go over x is 1, and I'm going to put a solid line, and then all the points that are greater than that. So again, that makes sense because all those points out were x is 2, x is 3, x is 4, x is 1.5, all those points are where x is greater than 1. So all of those points work in our inequality. All right, example 3. We want all the points. When we multiply 3 times x, we get a number less than or equal to y. The boundary line is solid because it's or equal to. It has a y-intercept of 0, 0. The slope is 3. All right, and it's solid. And then we shade all of these points here. And again, the reason why those work, so if I pick the point 1 or negative 1, 1, again, this isn't something you need to do with your examples. It doesn't hurt to check. So if I substitute in the point negative 1 and then 1 for y, I get negative 3 is less than or equal to 1, which is true. And any point I would pick on that side would be true. And then any point that I would pick in the non-shaded side would not work. All right, so let's look at example 4. It says negative x is greater than y. Graph that in Desmos. Notice it's a dotted line. Goes to 0, 0. Here's another point on that. So we do my dotted line. Because none of those points on that line would work because it would be equal to, and we want it to be greater than. And then this says shade underneath. All right, all of those points would work in the inequality. So if I try it again, let's see, negative 1, negative 1, that would make this x a positive 1, which would be greater than the y, which is negative 1. So all of those points work. For example number 5, we want all the points when we subtract y and x. We get a number bigger than 1, and it's bigger or equal to. So there's a y-intercept of, looks like it goes to negative 1. It also goes to negative 1 on the x. Solid line. Ooh, that's a really good line. And then it shades underneath. And again, we can test those points. So if I want to test the point, let's see, 4, 1, which is right here. 4 minus 1 is 3, which is bigger than 1. So again, all those points work in that inequality. And finally, example number 6. Graph that. So I get 2x, all the numbers are going to multiply 2 times x, subtract 3 times y. I get something less than or equal to 6, so it should be a solid line. This goes through negative 2, it goes through 3 here. It's a solid line and shade above. So again, all these points gave me a true statement. Okay, so again, an inequality, you're graphing not only the line, either solid if it's or equal to, or dotted if it's not or equal to, and then you're shading. And everywhere that's shaded are points that make that inequality true. So now on the other side of the sheet, you should do examples 1 through 10.